What's up, everybody? Today we are back with another circles lesson. Today we're going to be talking about pi and the relationship of pi with a circle in this lesson called A Slice of Pie. Our warm-up, though, is we have to determine the area of a circle. Now, in order to do that, we have to remember, hey, what's our area formula for circle? So I'm going to write it right up top here. It is A for area equals pi r squared. Pi r squared, where r is our radius. So here we're given our radius in both of these circles. For this one, our radius is 7. So r equals 7. So we could write this out. Area A equals pi r squared. We could write A equals 3.14 because that's the number we use for pi times 7 squared. Then we get A equals 3.14. And what is 7 squared? 7 times 7 gives me 49. And then we just multiply here. So let me pull up my calculator. And we get 3.14 times 49. That's going to give me 153.86. Yeah. A equals 153.86 centimeters. And there we go. So that is our area. Now our area formula for our next one, A equals pi r squared. And then what can we do here? Well, we now know that our r is 9/4. It's that fraction, 9/4. So once again, we plug in what we know. A equals, for pi, we're going to plug in 3.14. For our r, we put 9/4. And we need to square this whole thing. So in our calculator, I'm going to put in 9. Oh, let me open up parenthesis first. Parenthesis, 9 divided by 4. And we want to square it. And we get 5.0625. We're going to round that to the second decimal. We'll get A equals 3.14 times 5.06. We get 3.14 times 5.06. There we go. We get 15.8884. So we're going to round this to 15.89. My area equals 15.89 meters. And there we go. Solved for our area. This is just a little warm up. Something that you should have seen before. Now, obviously, we probably all don't remember the area formula for a circle is pi r squared. So that's just a little reminder there. Now let's hop right into our main lesson. So as I said, we're talking about a slice of pie. And the way this looks is we're talking about sectors and segments of a circle. We're going to be able to determine the area of a sector of a circle, derive the formula for the area of a sector of a circle. We're going to determine the area of segments of a circle and use angular velocity and linear velocity to solve problems. Those are our learning goals. So starting off, we're going to find the area of a sector. In order to determine the area of a sector, you multiply the area of the circle by a fraction that represents the proportion of the area determined by the central angle measure. So in order to do this, we find the area of our circle, and then we multiply that by our central angle measure over 360, right? So another way to write this is what we have down here, where our area of the circle is this pi r squared, like we saw in the do now. And then m is going to stand for our central angle measure, and we put it over 360. So we get A equals m over 360 pi r squared. Nice and simple. It's nothing too complicated. Let's see it work. And our first thing that it wants us to do is the radius of the entire dartboard is approximately 225 millimeters. The innermost circle of the triple ring on the dartboard has a diameter of approximately 200 millimeters as shown. This is just a setup. There's no question here. Now we get to our question. And it says, calculate the area of each sector of the innermost circle of the triple ring. Now we might say to ourselves, how can we do this, right? How can we calculate the angle of each of these sectors, right? Well, the way we could do this is we could count how many sections are there here in the inner ring. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and there's 20. So what we could now do is we could say, well, if there's 20, and if we're saying that they're all equal size, I know that some look a little different than others, but they should all be equal size. So what we could say is 360 divided by 20. And that's going to give us an angle measure for one of these sectors. So when I do that, 360 divided by 20, we get 18 degrees. So each sector is going to be 18 degrees. Measure of each sector. That's what that is. Measure of each sector. Now we could use this, right? Because we could plug it all in. Now, we're also given our diameter of this inner circle. We don't want the diameter of this. We want the radius, right? So our radius is going to be half of that, which is going to be 100 millimeters. Now we have our radius. We have our measure of our inner circle. We could rewrite our area formula for a sector, which is A equals M over 360 times pi r squared. And now we can plug things in. We're going to get A equals 18 over 360 times 3.14, 100 squared. And we could plug this into our calculator. Well, we're going to simplify it. So we get, actually, we could plug this all into a calculator if you're using the Desmos. You could just type in, drag it on over to show you. Here's my Desmos. I already typed in 18. We click divide it by 360. You just click outside of that fraction. And then you do open parenthesis, 3.14, close parenthesis, open parenthesis, 100, close parenthesis, square. And here we have our answer. We click enter, and it's going to give me 1,570. So we get, when we multiply all this out, we square that 100, we get A equals 1,570 millimeters squared. We're talking about area, so it's millimeters squared. And there's our answer. That's the area of each of those sectors. So that's how we find the area of a sector in a circle. Now let's talk about the area of a segment. And what is a segment of a circle? Well, a segment of a circle is a region of the circle bound by a chord, and they include an arc. So in this example, we have an example of a segment of a circle, and it's this little slice here, this shaded in piece. This is name the chord in the arc that bound the shaded segment of the circle. So the chord is going to be AB, will be chord AB, and the arc, or sorry, that's the arc AB. My bad. And the chord is going to be chord AB, which is AB, the line segment, which is right here. So actually, let me change those colors, because this is going to be, whoops. This is, that's the arc AB. And then change color. And we have chord AB is that. So we have our arc and we have our chord, and they make a segment, which is that shaded section. So our area of this, and now guys, I'm not expecting anyone to memorize the area of a segment, this formula, right? So the formula is similar to our last formula for the area of a sector, where it starts off the same, m over 360 times pi r squared. But now we do minus 1/2 base times height, right? And it says up top, you may not always be able to inscribe a shape inside a circle that you can easily determine the area of. But you can always determine the area of a segment by subtracting the area of the triangle formed by the two radii and the chord from the area of the given sector, formed by the two radii of the included arc. All right, so our next problem, it says James covers the entire top of his piece of pie with whipped cream, but doesn't like to eat the upper portion of the pie crust where it's the thickest. And it tells us that EP and EI are radii of a circle, which means that they are going to be equal, right? And then it says that EP is 4 inches, which is already labeled, so that means EI is 4 inches. And it tells us that PEI is going to be 60 degrees. So PEI, 60 degrees, right? Now, one thing that we have to know here, and I know because I do math for a long time, is we have to draw our height here. And what's going to happen is it's going to cut this triangle in half. And the triangle that we're starting out with is actually an equilateral triangle. But when we cut this in half, it's going to give me a 30-60 triangle, which then we could use our ideas of that. And we'll find out that this little shorter section here is 2. That means our hypotenuse here is 4, which means that this is going to be 2 radical 3. And that's my height. My height is 2 radical 3. And now I'm not saying we all have to remember or know how we got that. What we need to know is, hey, my height here, h, is 2 radical 3. My base is going to be 4. Base is 4, right? So that's for our formula down here. Our m, what is our angle measure? M equals 60 degrees. And my radius, r, is also 4. Right? And now we have all the information we have to plug into our area formula. So we're going to put A equals, and it's M over 360. So we get 60 over 360 times 3.14 times R, which is 4 squared, minus 1/2 times 4 times 2 radical 3. Gross formula. So we're going to take it one step at a time. First, let's simplify 60 over 360. So we're going to get A equals 1 over 6 times 3.14. And now let's do 4 squared. What is 4 squared? That's going to give me 16. And that's all we have to simplify, right? So we get 1/2, 4, and then 2 radical 3. Now, what we're going to do first is we're going to multiply the numbers on our left side. So we're going to bring out our calculator. And I'm going to drag it over so we can see this get done. Right? And we're going to do 1 divided by 6. Click out of it. Open parenthesis, 3.14. Close parenthesis. Open parenthesis, 16. Close parenthesis. And we click enter and we have our answer. We're going to round to the second decimal place just to keep it even. So now let me write that down. So I need to bring this up. We get A equals 8 point, I already forgot. We get 8.37. So 8.37 minus, and now we need to do this section here. So we need to simplify that section. So we get 1 divided by 2, open parenthesis, 4, close parenthesis. Oh, I made a mistake. I forgot to click out. See what happens when you don't click out of your fraction? It puts the 4 in the bottom. We don't want that. So open parenthesis, close 4, close parenthesis. We want it like this. And then open again, 2, square root 3. Click out of the square root. And we go close parenthesis. and we click enter, and we get 6.9, and we're going to round up to a 3, so 6.93. 6.93. And last but not least, we just have to subtract these. We could get our area is going to be equal to, let's just subtract. So we get 8.37 minus 6.93, and we get 1.44 is our area of that upper crust. Now it's going to be 1.44 inches squared. And why is it inches squared? Because remember, area is two-dimensional. So then our unit has to be in 2 dimensions, which just means that you throw the square up top there. And there we go. We did a problem. And now this problem seems super complicated, but it's just being able to figure out, hey, let me write down each of my variables. M equals to 60, R equals to 4, H is equal to 2 radical 3, B equals 4. And I know that H was difficult to find in this problem. You're going to have easier problems where it tells you what your height of this triangle is, right? You're not going to have to find it. And then you plug them in, and then it's just being able to solve a formula or solve an equation, an expression. So let's do another one. So it tells us, it wants us to calculate the radius this time. It says the area of the segment is 9 pi minus 18 square feet. And we want to be able to find the radius. So in order to do that, what do we need to know? Well, we don't even need the minus 18 here. All we need is the 9 pi, right? And the reason because we just need to figure out some of these things, right? Now, what information do we have from our circle, right? We only need the 9 pi because if you notice, this is set up like this formula down here, where it has the area of the sector first, and then minus 1/2 base times height. This is the minus 1/2 base times height. So if we get rid of this, we just have 9 pi, and we could set that equal to m over 360 pi r squared equals 9 pi, right? And we could plug in for our variables here. Now, what variable are we looking for? We're looking for r. That should stay there, right? That should stay there. Now, the variable that we need to know is m, which is the measure of the angle, which is going to be 90. So m is 90 because we have a 90-degree angle there. We get 90 over 360. And then what's going to happen, what we could do, then we get pi. I'm going to separate these. R, whoops, squared equals 9 pi. And we could divide pi on both sides, right? And when we do that, they cancel, they cancel. We don't have pi anymore because we had it on both sides. We could get rid of it. So now we have 90 over 360, which we could simplify. And it's going to give us 1 over 4. 1 over 4 r squared equals 9. And what we could do here is we multiply by 4 on both sides to get rid of it. It's going to cancel here. And we're going to get r squared equals 36. Last but not least, we take the square root, both sides. We get r equals 6. Got our answer. R equals 6. Let me fix this 4 here. I don't like the way that looks. That's a 4 that should be here. So if you got confused about what I did here, just watch this little section over again because I know I went through it a little fast. I apologize. So just watch it over one more time and listen to how I explain it. Maybe copy it down and then rewatch as you already have the work copied. You could just pay attention and listen to what I'm saying. So let's do it again. Now, the area of the segment is 10.62. And we want to calculate the area. Actually, what do we want? Area of the segment is 10.62. And calculate the radius again. So now we just have to set this whole thing up, right? And now this is going to be a little more complicated because we don't know our radius. But the thing is, our radius is also going to be the base and height. So there's going to be some combination we could do here, right? We're going to be able to get rid of some stuff, and then we're going to be able to combine things, right? So that's something that we'll be able to do. So let's write out what we know. So we know that 10.26 is our area of the segment, which is down here in our formula. And we're going to set that equal to m over 360 times pi. I'm going to break it up again, times r squared minus 1/2 BH. Now, a couple things we know. We know that we have a right angle here. We also know that the base of my triangle, OB, is also a radius, r. And the height of my triangle, OA, is also r. So for our base and our height, we could plug those in as r. So then our next step here, what we could do is when we start plugging things in, we could get 10.26 equals m, which is going to be 90 over 360 pi. And then we're going to get r squared minus 1/2. And then we're going to have r times r, because we plug the base is our radius and our height is a radius. So they're equal. And we could simplify those and rewrite that as r squared. But we can also simplify some other things. So we're going to get 10.26 equals 1/4 pi r squared minus 1/2 r squared. Now we have to think back to our old algebra days. And there was this time where you guys probably heard of something called factoring, right? Factoring. And we could factor this r squared out here, right? And once again, these are harder algebra skills, but still good to see. So we could factor. And what's that mean? We could take this r squared out of both of these. We could get r squared, open parenthesis, 1/4 pi minus 1/2. And now what we could do is, we don't have any variables in here. We could solve this for a number. So I could plug that into a calculator, which I'm going to do. So we get 1 divided by 4. And then we need our pi symbol. Where's pi? So we'll use 3.14. We click out and we do times 3.14 close minus 1 divided by 2. We click enter. And it's going to give me 0.285. And we're going to leave it like that. I know usually we round to the second decimal, but since it's just such a small decimal already and there's no whole number here, we're just going to leave it as 0.285. That's going to give me 0.285. And that's the section here in this parentheses. Now what can we do? Well, we could say 10.26 equals r squared times 0.285. And since we're doing r squared times 2.5, we could divide that from both sides to get rid of it. Like so. Here it's going to cancel. And we're going to be left with, I'm going to rewrite this over here. We'll be left with r squared equals, I'm going to do 10.26 divided by 2.85. 0.285. We click enter and it's going to give me 36. And then we do r squared. Take the square root of both sides and we get r equals 6. Same answer as last time. Same answer as last time. Well, it's the same setup. That's probably why. They just gave us the 9 pi minus 18. 9 pi minus 18 is going to give me 10.26. Surprise, surprise. And there we go. We get r equals 6. So now let's just see an application of this, right? And it says a dog is tethered to the corner of his rectangular doghouse with 10-foot chain. The chain keeps the dog within 10 feet of the corner. I'm sorry that I didn't move the text around here and that is very sloppy. I apologize. I must have missed it. All right, so let's look at our problem. It says determine the area of the sector created by the 10-foot radius. So the sector that we want to find isn't just broken up by this. They're just telling us that this radius is 10 feet. The sector is this whole entire thing from one side of a doghouse all the way around to the other. So this angle here is what angle that we're going to be using for M, right? So in order to do that, that's going to be almost 360, right? But minus this 90, which is going to give us 270 degrees. That's a big angle. So remember, our area for a sector is M over 360, and then times pi r squared. We know M is 270. We know R is 10. So let's plug it in. Let's get this job done. So we get our area equals 270 over 360 times pi, which actually I'm going to not write pi. I'm going to put 3.14 times 10 squared. 270 over 360. We could divide both by 90. And that's going to give me 3 over 4 times 3.14. And then 10 squared, or 10 times 10, is 100. And now we just plug this into our calculator again. So once again, we do 3 divided by 4. Make sure we click outside of that fraction. Open parenthesis, 3.14, close parenthesis. Open parenthesis, 100, close parenthesis. We click enter and we have our answer. 235.5 is our answer. So the area of the sector is 235.5 and our unit is feet. Oh, sorry, feet squared because it's area. And there we go. So now it's saying, what is the radius of the smaller sector? And that's this little chunk here. They want to know this little chunk right there. And what is that radius? How can we find it out? Well, we know that this whole section is 10. The smaller section is 8. So we just do 10 minus 8, which is going to give me 2. This little sector right there, the radius of that smaller sector is 2. That's just using our surroundings to figure that out. And now it says, determine the total area or space the dog has to play. Well, we know this whole big sector, right? And the dog could still technically run in the smaller sector here. So we have to find the area of that smaller sector. And for that smaller sector, we know that this radius is 2, and we have a 90-degree angle here. So M is equal to 90, and R is equal to 2. Remember, our formula is M over 360 times pi r squared. So let's plug everything in. We get A equals 90 over 360, 3.14 times 2 squared. 90 over 360 is going to give me 1/4 times 3.14 times 2 squared is 4. So once again, pull out that trusty dusty calculator, and we get 1 divided by 4. Click outside, and then we do 3.14 times 4. We click enter, and it's just going to give me 3.14. Duh, I sure saw it coming, because it cancels each other out here. So our area here for the smaller one is 3.14 feet squared. And we have to go back to our last slide. What was our area for our bigger one? Or 2 slides ago? 235.5. So now we can add those together. And we get 235.5 plus 3.14. And why are we adding those together? Because it wants to know all the space the dog has to play. And the dog could technically play within this space, right? So we get all of that space. So we get 238.64 feet squared. That's my final answer. That's the total area that this doggo could play. Awesome. And that's all we got. Now, I know there was a lot of information here and there was a lot of formulas. So if you have any questions, please let me know, let your teacher know, whether it's Miss Harris or another teacher. Drop a comment down below if you have any questions, and I hope you all had a good lesson. Peace!